So in the last video, I went through a soil test report, what each of these sections meant, and some basic information about them. So we'll get a little bit more in depth here, and we'll take a look at two reports. These are comparing soils, and we'll look at when we're going through soil samples from a specific field or several fields, some things we can look at. These were from the same field, and it's a large field that is pretty much the same soil. It's a Hoytville silty clay loam, and you can see with our two samples here, organic matter is very similar. This is a well-maintained soil, so phosphorus levels are both at a good level. If we're looking, these are in parts per million. If you want to convert over to pounds, you basically just multiply parts per million times 2. So if we have 40 part per million of sulfur, we've got 80 pounds per acre available. So pretty easy conversion there, and that might make it a little easier if you're trying to make a recommendation off of this, looking at pounds versus part per million. On our potassium, we're at 208, 223. Our CECs are very similar, so 15.7 to 16.2 is not a big difference. So when we look, our potassium levels are both sufficient, and with our CEC, you combine both of these two to come up with your potassium recommendation. So the amount of potassium you have available is also determined by the CEC. And you can see our percent potassium here is very similar. In our percent cation saturation, our base saturation, these two samples are fairly equal for the amount of potassium they have and the availability of that potassium. When we think about potassium and recommendations, the higher your CEC, the more potassium you're going to have to apply. So when we think about our buffering capacity of the soil, so the CEC holds on to those cations like potassium. They're not necessarily going to be available to the plant. So if we have a really high CEC soil, you can pack a lot of calcium or a lot of potassium onto the soil that will be bound and may not necessarily be available for the plant. So in this case, we have a good level. We have a decent CEC, so we're going to recommend a replacement for both the phosphorus and the potassium. If you were at a very low level, that's where you're going to use your build equation and you're going to apply more than the plant needs. But since we are in a good place with both phosphorus and potassium, we're just going to replace what the plant takes. Magnesium, calcium, we're in a good range here. Not necessarily a need to do much at this point. Our soil pH, we're in a good range. The second sample, it's on the bottom edge. So we may consider a variable rate application of lime here. And we're going to just try to get this 6.0, maintain it at 6.0, get it up to 6.5. We don't necessarily want to pour a bunch of lime on there, especially if we're looking at applying lime as a whole to the field, because we're already getting up to our ideal range with this first sample. And if we're liming based off that second sample, we may be over liming. So if you're seeing big differences in your soil pH, that's where you want to consider variable rate. Like I said, we usually skip the sulfur micros down here. I tend to go off the organic matter and off of a tissue test in season to make decisions on these two. So here is an example that I came across in a field. The customer called, they had some yellow patches in their soybeans. We went out and looked. It looked like potassium deficiency. I'm going to use a highlighter here. So when you look at that soybean leaf, we've got a yellow leaf, and then potassium deficiency usually shows up. We've got green on our leaf with a yellow, almost halo around the edge. So potassium is going to show up as a green leaf with a yellow halo around the edge. And I went and pulled 2 soil samples and 2 tissue tests. And that's a good way when you're out in the field and you see something different in one part of the field versus the other. Take both a soil sample and a tissue test, and that can help you hone in on what's going on. So I sent in samples. So we've got K-def, so that's potassium deficient. That's where we were seeing the symptoms. And potassium sufficient, that's where we were seeing green leaves. We weren't seeing that yellow halo. When we look, our organic matter is fairly low in these soils. And when we look at our CECs, we're down at a 6, we're at almost an 11. So very low on the CEC, low on the organic matter. Something that jumped out, we're very low on phosphorus. And potassium, even though we were only seeing the deficiency symptoms on one sample, they're both critically low. And this is where this percent cation saturation and cation exchange capacity comes into play. If we look at our percent saturation, we're able to compare these two soils. So even though our potassium levels here are 55 and 49, those are very close. We would expect to see the same thing happening with potassium in both of those, but we can see that our CEC is half in this sufficient area of what it was in the deficient area. In this deficient area, there was more binding sites in the soil. So the soil was better able to hold on to this potassium, and you can see this percent cation saturation is half of what it was in the sufficient area, even though their potassium levels were similar. So we have more potassium bound in the soil. It's not available for the plant. And in this first sample, we saw that we had deficiency because even though the amounts were the same, there was less available. Where in the sufficient area, we saw that with the lower CEC, more of that 55 pounds was available to the plant than it was in the area with deficiency. Now, the big thing here was when we pulled a tissue test, we found that indeed both plants in those areas were deficient for potassium. So even though we weren't seeing the symptoms necessarily in this sufficient area, both of these soils were critically low on potassium, and both of the areas we sampled in the plant tissue were critically low on potassium. So even though we didn't see those symptoms in one area, it was still deficient. And that can happen where you think everything's hunky-dory, you pull a tissue test and find out that for some reason you're deficient. And that's why I like to tissue test in season, soil test in the fall. And if we run into a problem, I both soil test and tissue test, because we would have thought, based off the soil test, that this deficient area was the only one that really needed potassium in season. And because we were seeing these symptoms on one part and not the other, and it looked like there was enough potassium available, we might have just gone ahead and made this application to the deficient areas when both were actually deficient. So that's a way to compare soil samples. If we have any questions on these, please send them. I'm going to do some more in-season videos on how to soil sample the proper way, proper technique, how many samples to pull from an area, and then also how to set up a sampling either grid or zones. And I'm also going to do an in-season tissue testing video where we will go out, show you how to pull, package, and submit samples, and then also how to interpret that once it comes in. So thank you.